Alright, so let's go ahead and take a look at this free response. So, yesterday you had a chance to probably get through most of it, or at least try it and get a chance to look at everything. So we'll go through the answers today. Since you already have some answers, we'll go ahead and go question by question and just reveal some answers. So before I show you an answer for this one, what did you get as an answer for the first question? Why does the provided equation support the fact there is a horizontal asymptote that is not on the x-axis? Does anybody have an explanation for that? Go ahead.
Because the equation's not bottom heavy.
Okay, it's not bottom heavy. What is it then? If it's not bottom heavy, what is it? Did you come to a conclusion on that?
Equal.
Okay, it's equally heavy. Okay, so for the first one, if you multiply out your factors, top and bottom, yes, you will still have a's in your answer, that's okay, but if you multiply them out, you get standard form. Then you can look here at your powers. It's equally heavy, that both the power of 2 on the top and the bottom says they have the same power. So from those roles that we had written 2 days ago now, since the powers are equal, your horizontal asymptote, y, is equal to the ratio of the leading coefficients. And that's not y equals 0. So as long as you have something close or the same idea in your answer, it doesn't have to be worded exactly the same. As long as you have the same idea down. Any questions about that first one? Alright, so the second one says find the correct value of A, show your work, and justify your thinking. Does anybody know how to explain how they found A? So again, A would be that coefficient on the top. How did you find it? Go ahead, Tori.
I said if equals negative 4 is the only value that would get you negative 2 by dividing a over 2.
Yeah, so you have to use the given information at the top. They tell you the horizontal asymptote is at negative 2. So you said A over B, which B is 2 value. You can take that from the bottom right here. A over 2 is negative 2, so A has to be negative 4. Very good. Again, that's the leading coefficients. Does the graph of f of x have any vertical asymptotes? Why or why not? If any vertical asymptotes exist, what are the equations? Do any exist? Are there any vertical asymptotes? Rebecca?
Yes, because one of the factors in the denominator does not cancel out.
Very.
So x equals negative 3 is the vertical asymptote.
Yeah, it does not cancel out on the bottom, the denominator. Well, that's at x equals negative 3, or the factor of x plus 3. And it's a vertical asymptote because it does not cancel. It's a non-canceling factor in the denominator.
Good morning.
Good morning. Does anybody have anything for the office? All right, doesn't look like it.
Okay.
Thank you. All right, the fourth question. Does the graph f of x have any holes in it? Why or why not? If any holes exist, what are the coordinates of the holes? So is there a hole in your graph? Yes, there is. At what x value? Okay, the x value is 2. They want the coordinates, though. How do you find the y value of a hole? We did this a few times. Rebecca?
You plug the x value into the simplified fraction.
Yes, you plug that x value, which in this case would be 2, into the simplified version. So f of x does have a hole at x equals 2 because the factor x minus 2 is a canceling factor. Here is the factored form. And again, we plugged in the negative 4 because we found that negative 4 for A. Cancel out the hole, so you have the reduced form that you plug in your x value. So you should get a y value of negative 11 over 10. That is the y value you should be able to get for your hole. So I'll give you a moment to finish checking your answers and copying that down. Does anybody need to look back up at A or B that I don't have up there? All right, how do we feel with this problem then? A little better than yesterday now? You see the answers compared to your answers? Were you able to get most of the problem? Most of the parts, if not all of it? Okay. We're going to go ahead then and go to page 265. We're going to go ahead and start the next section. Anybody still need a moment on this page? Marie, you good? Okay. Alright, so we're getting to the part that I told you we were eventually going to get to. Taking all these pieces together, and we're going to have to be able to do two things. We're going to have to be able to look at a graph, as we are in these ones, graphing rational functions here, and come up with the factored form and standard form equation, and then we are eventually going to have to take the equation and create our own graph. So we're going to try a couple examples together, and then once again I'm going to let you try a couple on your own. So let's look at the very first one. It says determine a possible equation that would represent each of the rational functions graphed below. Leave your equation in both factored and standard form. So we want both. So this first one, we're going to call these f of x. We're going to try to get the factored form first, because the factored form is easier to arrive at because you need to look at all the different aspects of your graph, asymptotes, holes, zeros, y-intercepts, anything like that to create your factors. So go ahead and kind of analyze this first graph. Look for any particular spots that look like something important has happened and try to think of some of the factors and where they're going to go, whether they're going to be on the top or the bottom or both, and then we'll start to put it together. So I'll give you a minute to look at it. Alright, so let's go ahead and try this then. So we're trying to put factors on the top and the bottom of this rational function. What kind of factors go on the top, the numerator? What kind of factors go on the top, Marie? Zeros and a part of the whole, because the whole will go on the top and bottom. Do we have any zeros? No. So there's nothing to put for any zeros. Do we have any holes? And what would be our factor for the whole? Be what? Okay, we're going to have an x plus 1 on the top. Since it's a whole, we know that's also going to go on the bottom. X plus 1. Alright. So since we're on the bottom now, let's focus on that. We know holes go on top and bottom. We've already taken care of that. What else goes on the bottom? What else goes on the bottom? Rebecca? Vertical asymptote. Do we have one? And what would be our factor for that?
X minus 1.
Okay, we would have x minus 1. So, setting up the factors, at this point, I can't really tell if we have everything or not, so we're going to multiply it out, put it in standard form. When it's in standard form, we can check those constants, make sure we have the correct y-intercept. Is there anything else that you, at this point, that you think might be missing? What haven't we talked about so far? Marie?
How the horizontal asymptote is the
Okay, we haven't talked about that yet. When we multiply it out, we can analyze the powers. And for it being at y equals 0, how should the powers work out? What are we looking for when it's y equals 0? We have the 3 roles if you need to look back. So looking at the picture, we know it's at y equals 0. So what should our final result be with the powers? Go ahead, Marie. Bottom heavy. Okay, let's multiply it out in standard form and see what we get. On the top, I still have x plus 1. On the bottom, I get x squared minus 1. Okay. Is it bottom heavy? Yes, so the horizontal asymptote is at y equals 0, so that makes sense. Now let's look at our y-intercept. Do we see it's right here? What value is our y-intercept at on the graph? It's all the way down here at -4. If you take your constant terms of the top over the bottom, do we get -4 yet? No. So how do you think we could get -4? Right now we have +1 over -1, so we have -1. How can we make that a -4? What value do you think is going to be easier for us to change? This one with the x squared or the one with the x on the top? If I, in this factored form, just add this 4 over here, does this change any of this so it won't work? Or does all of this information still work with the up above? Do I still have the whole at x minus 1 in this setup? Do I still have a vertical asymptote? If I multiply this 4 out, that would give me 4x plus 4. Do I now have -4 as my y-intercept? So really, I had the original setup here, but I didn't realize until I multiplied it out that my y-intercept wasn't correct. But if I just multiply by a constant on the top, that 4, I'm able to make that as a -4 for my y-intercept. Now that won't always happen. In this case, we had to multiply by this constant to make this work. You won't always have to multiply by a constant. Sometimes the problem will work out with your factors. Does anybody have any questions about any part of that? Are we okay with all the steps we had taken to get there? All right, the next one I want to look at with you would be this one diagonal in the bottom corner, because it looks a little different than the other two. So let's go ahead down to this bottom one. So we'll just call this one f of x also. It doesn't matter for purposes of this. Call it f of x. And again, we want to put factors on the top, factors on the bottom. And you already said the factors on the top are either going to be factors that include a whole or factors of what else? Wholes, or what else goes on the top? The zeros, yes. How many zeros do we have in this one? Take a look at your graph. How many zeros do we have? Marie? Yes, we have 2. We have one right here and one right here. So we're going to have 2 factors on the top for zeros. X plus 2. X minus 1. Do we have any wholes anywhere in this graph? No. So we don't have to put any factors for wholes on the top. On the bottom, we need to have factors for wholes, which we don't have any, or factors for vertical asymptotes. Do we have any vertical asymptotes? 2 of them, yes. So one would be here at -4 and one here at 3. So we have x plus 4 and x minus 3. Are there any other factors at this time that we need to take into consideration? Are we ready to multiply out? I think we're ready to multiply. Let's go ahead and we'll check everything else. I got x squared plus x minus 2 over x squared minus x minus 12. So let's check everything out. The powers are equally heavy. What does that tell us again? Remember, we had 3 rules. If they're equally heavy. Equally heavy powers. Ratio of the coefficients. Yeah. Yes, the ratio of the coefficients. So 1 over 1 is 1. Well, we see the horizontal asymptote is at 1, so that makes sense. Let's check the y-intercept. It says -2 over -12. Well, that would be like 1/6. Well, if we look, that's got to be really close to 1/6 right there. So do we need to multiply this one by anything else? Or does everything work? Yep, we're all good. Everything worked for this one. You don't have to worry about multiplying by any constants. Everything works out. This is your factored form and your standard form. So if you're okay with those two and no questions, I'd like you to go ahead and try the other two. So create your factored form, create your standard form, and we'll check those two in a moment. So this top one and this bottom one, go ahead and try on your own or with a partner. For the first one, the factored form, I got x minus 3 on the top. And this one is a little different. You probably had x plus 1/2 on the top. So we haven't been dealing with fractions at all, so that x plus 1/2, to make it a 1, if you multiply them both by 2, that'll give you the factor, instead of having that 1/2 in the parentheses there. So x plus 1/2 technically is correct, but when you multiply it out, you won't have the correct y value. So to get rid of that fraction, if you multiply that factor by 2, you would just have 2x plus 1. Multiplying it by 2 is not going to change that. Because whenever you solve for x, you would still get x equal to negative 1/2 for that one. On the bottom, I have x minus 3 and x minus 4. That was the whole, the x minus 3. The x minus 4 is your vertical asymptote. And again, after that factor is 2x plus 1 on the top now because I multiplied it by 2. Everything multiplied out works now. I have negative 3 over 12 as my y-intercept, so negative 1/4, which is like right there. Again, the negative 1/2 for the 0 right there. Equally heavy, so ratio of the coefficients, 2. And that is where the horizontal asymptote is. Are we okay with that factor changing it to a 2x plus 1? Alright. Go ahead and try the next one and then we'll go over it. So I got x plus 2 on the top and x minus 3 on the top. So there's the value for the whole and the y-intercept. And I had x plus 2 on the bottom. Again, that's for the whole. And then I had x plus 3. The x plus 3 on the bottom, sorry for that. The x minus 3 on the top for your 0. Multiplied out, you get x squared minus x minus 6 over x squared plus 5x plus 6. equally heavy, so the coefficients are 1 over 1, so the horizontal asymptote is at 1. So those are all 4 answers up there. Have I lost anybody? Confusion on any part? Or still doing okay? If there are no questions, we can go to the next page, but if there are any, we'll go over them. Alright, so once you're finished up, then go ahead, turn to the next page. On the back, given the equation of a rational function, below, develop a graph of each function. So they've given us the function, just like I said eventually we would have, and down at the bottom we have a blank graph, so we're going to have to actually create all of it. So we're going to start out answering these questions at the top. They give us 1, 2, 3, 4, 5, 6 questions. Then at the bottom we'll start to sketch it. So some of these questions, most of these questions you should know how to do already. If you want to go ahead and get started, I'm going to work through them up on the board, but if you want to work ahead on these, that's fine too. The second one, they want an explanation too. So at x equals -1, that's a non-canceling factor. That's how you know that's a vertical asymptote. So just a brief description. From what I have on the board so far, any questions? Need an explanation? I can tell you what comes from where. Once you get to the very bottom, don't try the very bottom yet. I'd like to go through the very bottom with you once you get there. So at the top, we completely factored it and wrote the simplified form. In the second box, talked about any vertical asymptotes, so non-canceling factors in the denominator, so x plus 1. Any holes, so that's the canceling factors, x plus 3 canceled. I took the reduced form and plugged in -3 and found my y value of the hole. In the next box, the horizontal asymptote, look at the degree. In this problem, the degree happens to be the same, equally heavy, same degree. Take the coefficient, so I got 2 as my horizontal asymptote. Zeros, I took the non-canceling of the top, the numerator, set equal to 0, so I get x equals 1/2. Then I used all the values I found up above to create my domain and range. Again, the domain, x values that don't work, you have to take into consideration. For the range, it's the y values that don't work. So pay attention to asymptotes and holes. We about ready for the bottom graphing part then? Alright, so on the bottom, they want us to put all of these pieces together. We need to find everything. So, one piece of information that we didn't find yet, that we normally talk about the constant terms, we get what as an answer? Let's find that first. What do the constants tell us from the top? We have a constant on the top over a constant on the bottom. What does that give us? Some key part of our graph. They didn't ask us about it, but what does it tell us? Talking about the constant over the constant. Yeah, y-intercept. So let's just label that. Y-intercept is going to be -3 over 3, so -1. Alright, so that's just some more information that we're going to need. It says sketch a detailed graph. So we're not just going to draw some lines. We have to actually make it as accurate as possible of the function on the grid to the right. You will need to use a minimum of 6 points. 3 points on each branch. So once we get started, that will make a little more sense. Before we actually start graphing the actual function, let's take care of any information from up above that may be important. So we talked about vertical asymptotes. So we found at x equals -1, there's a vertical asymptote. Make your asymptotes dotted lines so you don't confuse them with your function. So at -1, we should have the vertical asymptote. Any holes? Well, it said we found a whole x value and y value up here. So that coordinate was -3 and 3.5. So at -3 and then 1, 2, 3.5, we have a hole. Okay, so we can take care of that. Then it says horizontal asymptotes. We found that it was the coefficients. So 2 divided by 1 is 2. So at y equals 2, it says we have a horizontal. So draw your dotted line. That's our horizontal asymptote. Zeros of the function, in other words, x-intercept. Well, we found the x-intercept was at x equals 1/2. So at x equals 1/2, there. Okay. Domain and range are there. We have the y-intercept. The y-intercept we just found is at -1. Alright, so it says domain and range at some points they're going towards negative and positive infinity. Both of them. So, since we know that we're going from negative to positive, we see that we're going to have a piece up here because we have a hole here and we have a piece here. So we're going to have parts of it that go down towards negative infinity somewhere and pieces up here that go towards positive infinity. So what we're actually going to do is we're going to create a little chart to help us get an idea of what's going on, x and y values. And again, it said 3 points on each branch. Well, I'm going to have a branch up here and I'm going to have a branch down here. So you can kind of look in what kind of x values you may need. For this top one, we already have the point at -3 there. So I think we could probably use -2 and -4 on either side of it. So -2 and -4, we'll use those x values. Down here, we already have at x equals 0. So maybe we do 1 and 2. And again, remember, we already have a point there and we already have a point there. So it said 3 on each. So we only need 2 more for each side. And now what you do, you can plug this right in. You can plug it into the reduced form up here. Oh, you can plug it into this one, because if you plug anything into these terms that cancel, they're just going to cancel out anyways. So you can plug into the reduced form right here, 2x minus 1 over x plus 1. That's what we're going to plug these into. So I'll show one of them here. It would be 2 times -2 minus 1 over -2 plus 1. -5 over -1 equals 5. So that's the actual steps. Rewrite these. And I'm not going to show this step for all of them because I don't have enough room for it. When you're checking your problem, definitely on a free response test or quiz, you should go through this in each step to make sure you have the correct answer. But for -4, after some reducing, you would get 3 as your answer. For 1, after you go through some reducing, you would get 1/2. And 2, you would get 1. Again, I used the same equation for all of those. So now we can go ahead and graph those other points. -2, 5. And -4, 3. Can we kind of see the direction that graph may be going in now? It's kind of got that curve to it, so we're going to be following the asymptote. We're going to go through those points. Remember, that's a hole. Stop and start on the other side and go towards positive infinity. So we went through those 2 points, but this was a hole here. Remember to leave that open. Now let's try the other side. 1 and 1/2. So right there. And then 2, 1 right there. So again, we can kind of get to look at this one. It comes up. There are no holes here. It goes through all of those points. And we have successfully graphed our first rational function from scratch. Found all the pieces of information at the top. We're able to put them all together. Now to double check, look at your domain. Make sure your domain and range makes sense. Negative infinity to negative 3. So from over here to negative 3, yep, I have a hole there. Then I go from negative 3 to negative 1. Yes, I have a vertical asymptote. Then I go from negative 1 to infinity. Well, that makes sense because I have no holes over here. So the domain works. Range, negative infinity to 2. That makes sense, horizontal asymptote. 2 to 3.5. Well, that's the y value of my hole. That makes sense. And then 3.5 to infinity. So everything does check out. Domain and range work, and all the pieces from up above came together to create this graph. How are we doing out there? All right. All right, so at this point, we have a few more examples, but I'm going to use those tomorrow to give you some more practice. So the rest of today you can use to start some of those homework problems, maybe try some on your own, get some individual practice.